Thank you, Farah, for the introduction. So let's skip the intro and let's get to the topic. Our agenda for today is going to be the needs for big objects, what are big objects, and consideration of usage, and big objects indexes, and what are indexes in big objects. Okay, so let's start our session by a small question. So does anybody has an idea of what we might need big objects for, or when should I consider big objects as a solution for the current requirement or something?
I think maybe for data archiving.
Yeah, this is one of the use cases, yes. Okay. We mainly have three use cases, like you said, Mustafa, for audit and tracking. Okay, like the field history archive. This feature that Salesforce natively support keeping track of the field history up to 10 years worth of archiving. This is built on big objects. Okay. The loyalty programs and customer interactions and billing information. This is also can be stored in big objects. User activities like code reviews, time entries, and etc. This also can be used in big objects. So big objects, in summary, this is that kind of Salesforce objects that store hundreds of millions or even billions of records in your organization. Okay, and it has several characteristics like the custom objects also always have the suffix b, like the custom objects also have the suffix c. Okay. I would like if anybody has a question or something to interrupt me, just to keep the session interactive. Okay. So what's important to know about using big objects? Like I said, it always has the suffix b in case if you're creating a custom big object. Okay. And the custom big objects does not count against your organization storage limit. Okay. So there are several considerations you need to put in your mind while using big objects. Big objects does not support the standard UI for Salesforce. It has no tabs, no digital page, no detail pages, no list views. Okay. It only supports. So if I wanted to create something to visualize my big objects and my big object records, so what should I go for? The answer is gonna be Visual Force pages, Lightning components, and you have to consider also that big objects does not support the standard controller. So you cannot in Visual Force page, you cannot do this page standard controller your big object name. You have to use a standard controller like a standard object or a custom object, and then add an extension to your big object So do you guys follow up with me? Okay.
So far, so good, yeah.
Okay. So this is need to be considered when developing a Visual Force page or a Lightning web component. Okay. It only supports object and field permissions only. Supports limited data types. You cannot have the full data types that Salesforce support in the normal Salesforce objects. You only have the lookup relationship, the date time, the emails, number, phone, text, and text long okay, and URL. Those are the only data types that are supported in big objects in Salesforce. Okay, as I mentioned before, the big objects does not count against your org storage limit, but you only have 100 big object per org. Okay, you cannot use triggers, flows, or processes, process builder on big objects. This is one of the limitations. Okay, you can manipulate your big object using SQL, async SQL, and metadata API. Okay, but you have also take notice that you cannot build a report on a big object, but you can use Einstein analytics, and it does not support the SQL operators like not equal, like, not in, and excluding and including. So this is a bit limiting. I bet every one of you is asking, so what is the benefit of having a million of record when I cannot create a report or something beneficial from this? Okay, this is we're gonna cover in the upcoming slides. Okay, so
Sorry
yes,
to
yes.
interrupt you over there. What do you mean by async SQL?
Async SQL is this type of SQL that run in asynchronously in the background. It runs in the background and then it returns the result later on. You still there?
Okay. Yeah. Actually, I never used it, so just curious to know.
Yes, yes, no problem. You can ask whatever you want. Okay. So let's first talk about indexes. So we mentioned that you need to have at least one index at your big object. So can anybody tell me about the definition of an index? What are indexes? Okay, indexes, like, imagine you have a pile of cards, and you need to get a definite, a specific number, like 10 of hearts or an spade is. Okay, so you will have to cover the whole 52 cards to find your card. But what if you classified this pile of card to 4 piles? Is the heart, the diamonds, the spades. Okay, you will find that you will reach your card much faster. This is the indexes that you classify your data in a specific way. Okay, so indexes in big objects. In the you must have at least one column in the index. You require this one column must be a required field. You cannot create an index on an unrequired field. Once you created an index, you cannot edit or delete it. So you have to start all over again from the start for the big object. So if I created a wrong index on a wrong field, so I have to recreate the big objects another for one more time. Okay. So let's see how we can set up our big object. Okay. From your normal setup screen, you type in the quick find search box big objects. You will find the big object screen in front of you. So all you have to need is create new and enter your object's name, your plural name. Okay, and you start to classify. You start to define your custom fields and relationships. Okay, here we have date field, new value, old value. This is for tracking field history. Okay, and you will find that we have the date field, the field, the date field, the field. Sorry, this is confusing. And the code and the user are the indexed fields. And we have the index position. This is the index order you have to consider while querying the big object. You cannot have, in case of you're using SQL, you cannot have gaps between your indexes. Like you cannot put in the where clause that index number 1 and index number 3. They have to be 1, 2, 3, 4, etc. Okay? They have to be ordered. This is a very important point to consider while creating a big object. Okay. As I mentioned before, only required fields can be included in an index. You cannot reference an unrequired field in the index. Okay. Okay. Here is an example of the SQL query. We are focusing here on the limitation of using the where clause, which only supports filtering using index field. Okay. So we have here select code field, new value, old value from code history. This is the object name. Where code, this is the number 1 index. Okay. And feed the number 2 index that I created. This is a valid SQL query. Okay. But here, this is an invalid one. If we read the SQL query, we will find that we put field, the field __ C, which is position number 2. So we are having a gap in our SQL query. Okay. So this is not valid. We have to start with the code in index field, okay, because it's the first position. So any questions so far?
So I understand.
Okay.
Go ahead.
Ladies first.
I actually had a question. You said that big objects, you can only have 100 big objects in an org. Is that available for any org, like for any, there are professional, enterprise, unlimited. Is that like a general rule or it's specific to an org?
As per my knowledge, they didn't mention for a specific license or a specific org type. But I can look up more for it and get back to you.
Okay.
Okay.
So I believe I got your point, Karim, about the indices. You made this clear, yeah. And yeah, of course, it's obvious why we need an indices while dealing with such big numbers of data. Salesforce designed this to handle billion of records. So in Salesforce, normally you can handle up to 5 million records in a Salesforce object before we consider this large data volume. And after that, you need to take some considerations and maybe have something to deal with such large data volume. And you need to really think about it, whether you need such amount of data inside your cloud instance, or you need to archive that, as you said before. And as one of the objects or the ways to archive the data, either to offload that into an external database that can be in the cloud or in your premises, or of course, big objects, as you said. It was new for me that you said that Einstein Analytics work with big objects. Thank you for sharing this info. I just want to clarify this part about the indices and the indices order. So I understood the point that, yeah, we need to respect the index order.
Yes.
But we should not, or we don't must to include all fields as part of the index in the SQL query. I can just specify the first column of the index as part of my SQL, and then it will work. Or I can respect it till the end, of course, the first column, second column, third, fourth, yes, and so on.
The point is you cannot have any gaps in your SQL query. You cannot include your first index, then your fourth index, you have to, if you're gonna use the first one only, use the first one. If you want to use the second one, then you have to use the first one and second one. If you want to use the third one, you have to use the one, the first, the second, then the third.
Got it. Okay.
Okay. So this is for the sync, the SQL, the normal SQL query. Okay. Just to digest the concepts, think that you already have, like Ahmed said, a billion of records. Okay, which is a very, very big number of records, which will take like ages if we handled it in the normal relational database way. Okay. So let's get to think SQL and the real power of big objects shine here. Okay. Async SQL is a SQL query that runs in the background in order to get your data, like the SQL query. But if you want your results immediately, you use SQL instead of async SQL. So one of the main benefits, or the biggest benefit for the async SQL, is that you can have a subset of your huge data set to a custom Salesforce object, a normal Salesforce object, which will be used in everything you are familiar with in Salesforce system. Okay. So we have here working with dataset filtering. This is a SQL query. Okay. Here we created a SQL query to filter a specific type of data, where field equal stage, وfield history type equal opportunity. It will get all the data from the archive table, or the archive, sorry, big object, with this condition, and load it in a custom object, normal custom object. Then you can have your reports on this custom object. You can have everything that you used to use in your Salesforce. Okay. I believe someone sent something on the chat. Okay. Okay. Then there is another technique in loading data to custom objects. It's called course aggregation, where we use the grouping. You are querying the data to get a group of records to use it in your also reports and analytics. Okay, or your normal use like process builders, reports, etc. Okay. So one of, let me check the chat. Okay. Oh, sorry. Okay. So how can I use async SQL queries? You can log into Workbench, and from queries you can select SQL query, async SQL query. Okay. Here you can start define your query in the query editor. You can select your source object here, which is code field history __ b, which is refers to it, that is a big object. Okay. Then you can start creating your query, like here. Here is the course aggregation query. Is selecting the code, the field, calendar year, counting number of updates, then grouping by code and field. Okay. Okay. Then when you click next, it will take you to the custom object that you need, that you want to save the result in. Okay. Here is a target object. This is a normal custom object, big object report. Okay. We are putting each target field in one of the custom object fields. Okay. Then you submit the async SQL query. You will have a job ID that is generated for your async SQL job. Then you can use this URL to know the status for your async for this job, like this is completed, still in queue, or finished. Okay. So when should I use SQL and when should I use async SQL? If you want to have the results displayed immediately in the UI without need to be waiting, okay, you need the results immediately to start manipulating it using Apex. And you know that the query is returning a small amount of data, okay? Then SQL is your choice. And when should I use async SQL? You should use async SQL when you are expecting that your return data will be millions of records. This will take time, so there is no point that you wait for this data. I think this is not doable. You want to ensure that the query is completed, and you need to do aggregations like grouping for the data. Okay, and you need, of course, to create reports or process builder based on the subset data you extracted from your big object. Okay. Is everything?
We have a question, Karim.
Sure.
When we move rows from custom object to big object for archival or vice versa, like retrieving from a big object into custom objects, do I have duplicate data at this time? Someone is asking this question.
And vice versa. I believe yes. Yeah, I think the way that Salesforce stores the big objects data is different than the custom objects. The way that Salesforce itself in the back end stores the data in its data centers or something, I think it's completely different because big objects are meant to handle billion of records, which is huge. So I think when you extract this this subset of data and store it in a custom object, I think there will be some sort of redundancy. But I can get back to you with an accurate answer. This is my interpretation for the whole thing.
It is an accurate answer. Yes, right. The data will exist in the big object and in the custom object. I think Vivek's point is that do we need to handle the delete ourselves? So it is not a move operation, it's a copy operation, as you said, Karim. The data will reside here and there, and you need to guarantee that after the data is moved to the big object, you can move it from the custom object or from the standard object so that we archive the data and get rid of the large data volumes.
Yes. Okay, thank you, Ahmed, for the addition. Imagine this powerful tool when you have millions of or billion of transactions, like you are like Amazon. You have millions of orders daily or billions each monthly. So you have to store your orders data in something. So the custom objects and standard objects will not be a much benefit here. So this is where the strength of big objects. Some might ask, why don't I go and seek a third-party application that handles this amount of data for me and everything? In my point of view, you do not need to have the headache of integrations and everything regarding using third party, while Salesforce offers you a very powerful solution for having very big objects, a very big amount of data like this.